everyone, and welcome back. In this lesson, I'm going to show you some features specific to file geodatabases that make them a nice workspace, and a few things about limits and considerations that you should be aware of when using them. We'll go over some things you need to know when sending file geodatabases to other people, and also different data types and benefits of using them. So to start with, I want to point out the importance of viewing your geodatabases in ArcMap rather than in Windows, because when you view your folders that have the .gdb extension, the true file geodatabases that I've created through the new menu here, in ArcMap or ArcCatalog, it can understand this data, it interprets it correctly, and we can use the data. It does the same thing for personal geodatabases. So if I expand them, it understands them as a geodatabase. But Windows does not. So if I try to navigate to the same location as this geodatabase in Windows, I'll show you what I get. So here's the folder that contains it. And what I see is a demos.gdb folder. Windows sees it as a file folder over here. It doesn't see it as a geodatabase. It doesn't know what a geodatabase is. And if I click inside of it, I just see a bunch of random files. It's a proprietary format that Windows does not understand, and I should not add files in Windows. I shouldn't remove files in Windows. Those will both corrupt the geodatabase. Instead, I should understand that I don't really want to mess with it in Windows unless the only action you can do in Windows is you could delete the whole thing. You could click on it and hit the delete key on your keyboard and remove the whole thing. I'd still say do that in ArcMap, just keep everything clean. But everything else, removing files once you're in the folder, don't do that. But what you need to know is that if you want to send this whole geodatabase to somebody, you need to send them this entire folder. So if you want to send it over the internet or something as a single file, you need to right click on the folder, and if you have zip compression software installed like 7-zip, which is free, you can use that, or if you don't have it installed, you can use the send to menu in Windows. And if you go to send to, you can select compressed zipped folder, and it will start compressing it and creating a single zip file for you to send your data. And here it is. So it has the compression dialog, but it's also creating the folder for me here. And that way I will have one file to send the geodatabase to people with. And then once that's complete though, in Windows I can right click on it or double click it to open it up and extract that information out to a new folder again. Okay, let's also take a look at some of these data again, and let's bring in our California counties layer. And if I go to the attribute table, I want to point out a couple things. First, these two fields get automatically added in file and personal geodatabases. So that's really nice. These get automatically calculated if I update the actual feature information in the layer and save it. So we automatically get these two fields with up-to-date shape information. Let's also take a quick look at the add field box, because when we start using shape files, we'll see it's a little different. If I go to double, I don't have to provide any more information for a field of the double data type, except that it's a double. Whereas in the shapefile, I'm going to have to provide some information about how long the field can be and how precise it should be. So it's kind of nice. It just manages this data for us. It makes it a lot less complicated for you to get started with. You know everything already from our data types lecture that you need to know in order to use data types in this geodatabase. The other thing that's not totally clear, because this data originally came from a shapefile, since so many people use shapefiles for data interchange, is that the database supports very long field names. So we could have used a field name of almost as long as we wanted, whereas shapefiles cap the field length at 13 characters. We can only use 13 letters or numbers to describe the shapefile's field name. So in file geodatabases, we can have very descriptive field names. Instead of name underscore cap, we could have had name underscore capitalized or something like that. Not a huge deal in this case, but there are plenty of cases where people start abbreviating their field names. Don't do that with file geodatabases. You don't have to. You can be descriptive and have people know intuitively what your fields mean without having to dig through your metadata. Similar to the limits on the names, file geodatabases also don't have really any practical limit on the size of the geodatabase or of any individual item in the geodatabase. They do have limits, but I'd be surprised if any of you managed to hit them. You would need probably a cluster of computers to hit them on to fill up a full geodatabase because you just don't have enough space on your hard drive. So they're really nice because they're not imposing any artificial limits on us, whereas the MDB format, that the access database format, the old access database format that personal geodatabases use, is limited to 2 gigabytes. So it makes it impractical to store any large rasters in there because rasters are usually pretty big. I have plenty of rasters on my computer that are larger themselves than 2 gigabytes. So not only will they not fit in the geodatabase, but if they did in a personal geodatabase, they would make it so I couldn't store anything else. In a file geodatabase, I can store all these things in harmony, and it will compress the data much better so that it's smaller on my hard drive and then even faster to access in most cases. So that's why file geodatabases are great. They can be a little bit of a pain from the viewing them in Windows standpoint, and they're proprietary, so open source software has to take some extra steps to use it. But you can use them in QGIS and other open source GIS packages as well. The last thing is that file geodatabases are theoretically good for multi-user environments. So if I had them stored on a network drive or something, and I was using this data, someone else can use it at the same time. Now, what happens is that if one user starts editing this layer, so if I start editing the California counties layer and somebody else tries to open it at the same time, they can view it, but they can't edit it at the same time. That makes some sense. Most people don't want to have 2 people editing the data at the same time because they could introduce conflicting edits. So ArcGIS prevents that. The big exception to that is our feature data sets, where if we have multiple items in our feature data set and we edit any feature class in our feature data set, the whole feature data set is locked, which means that nobody can edit any of the other feature classes at the same time. But again, they can view them. They can open them in ArcMap and take a look at them and add them to maps and stuff like that. Okay, one more thing is that geodatabases handle indexing for us. We haven't talked about indexing yet. Indexing is a great way to speed up access for large data sets. We can do it for attributes and we can do it for spatial locations. So we can go to indexes here and we can see spatial index, which is where ArcGIS figures out which items are in which areas so that it can very quickly draw our layers for us. And geodatabases automatically create these, where for shapefiles we would have to create them ourselves. We can also add attribute indices, or attribute indexes, and I can create one right now and say, well, I want to be able to search through the name field much more quickly. So I'm going to create an index on the name field, and I'll add it over to the field selected, and I'll click OK. And when I click Apply, it runs through the names field and starts creating an index of values in that names field. And this is going to make searches on that field or even joins on that field much faster. In particular, you do want your join fields to be indexed. So we'd want to make that COM_ID field that we've used in the past to create that relate index. So let's make a COM_ID index too. Note that these are 2 separate indexes though. They have to be separate. If they were the same, it would make it so that it would index them together so that searches for the 2 of them together were faster. But making separate indexes makes them each faster alone. And then I'll click OK to close out. Okay, that's it for this lecture on file geodatabases. I showed you how they appear in ArcCatalog, how they appear in Windows, and how to send them. I also showed you that it automatically adds area fields, and we talked about limits in file geodatabases, namely that they don't have very many, so we can store almost anything we want in them. And then also that we can edit one item at a time in file geodatabases, but others can view them if this is stored on a shared location. And also, we finally talked about indexing and how that speeds up our searching and our accessing of spatial locations and attributes. In the next lecture, we'll take a look at personal geodatabases. See you there.